So going to give it a couple more minutes so that people can actually get in here. Since we're still kind of starting things up. All right. Well, nobody else was joining. All right. Well, I'm gonna go ahead and start. What's up, guys? How's everybody doing?
Pretty good. Pretty good.
Right on. Cool. So this will be the first one that I'm gonna record. I'm gonna record this first part, and then I'll probably record presentations on challenge problems, and well, I'll just record the whole recitation, but I'll edit it. If you guys don't want to be in a little video, it's only going out to 50 students, or 48 technically. So let me know. But yeah, I think you'll only be in it if you're like speaking in the main room. Anyway, that should not mean don't ask questions. I'm recording this one because like you guys asked more questions than the other one. So yay. Alrighty, let's see. So I should probably sharing at this point. And here we go. Do y'all see what the name of my Wi-Fi is when I do that?
What?
Don't worry about it. Never mind.
I didn't see it.
Cool. All right. So let's go ahead and get this started with, is it report? Yeah, it is doing that. Okay, cool. So here we go. I can't see chat anymore. Oh, that's how that works. So when you're recording, you can't see chat. That makes sense. So let's see, fill in the gaps. So this first one, we're just doing Grignard's. This whole recitation is just working Grignards in different ways, getting you guys comfortable with basically manipulating both sides of the pieces. And so this first one, you've got this Grignard right here, which is working as a nucleophile. It's attacking this carbonyl group. You'll notice carbonyl groups can act as nucleophiles and electrophiles. So a lot less often you'll see this section acting as a nucleophile, but it's possible. Mainly because this is such a good electrophile. So this is such a great site for stuff to attack and then make new carbon-carbon bonds and that kind of thing. So that's what happened in this first part. And yeah, that's that first part. The acid workups go into alcohol. This other one, it's just a matter of redrawing it, and same deal. You could look at it as what's this. You can match this with wherever your alcohol is and say, oh, that's got to be a ketone. So then you just redraw it with a ketone and say that you added this. So I hope that makes sense. If not, talk to me. This last part is just a matter of counting your carbons. A lot of this is just a matter of keeping track of your carbons. Excuse me. And yeah, I numbered them, counted them. There's 3 carbons here, and then I needed my Grignard to actually make that connection happen. I actually redrew it over here to make sure I did it right. Highly recommend that. Nice little quick thing. Somebody just texted me probably about recitation. Don't worry about that.
I didn't understand that. Like that number two, the first part of it, where it was like A, B, and C. I had no idea what they were trying to communicate with the dotted lines.
It's just where they made connections. And it shouldn't be, um, yeah, it's where they made new carbon-carbon bonds. So the dotted lines are where like the two things were separate. Okay, everybody's saying they can't find the Zoom link on their calendar.
They forgot to register for it, probably.
And it's in the email. Like when you register, it's in the email. The numbers, at least.
Okay.
Also, it was kind of confusing because like if you go to Canvas on the calendar, it won't have anything with like the Zoom link, so you have to go back to
Yeah.
the Zoom email. So I think that's why.
That's what I did. I went to the email to get the link or get that
Yeah.
meeting ID.
Yeah,
Yeah, it took me a minute to get into because it doesn't have the link for today's. It just has it from last week and then next week. So I had to go back to
Yeah.
like the register part and just like do that again.
Okay. I'll just send that email. Okay, yeah, there's like, I've gotten 4 texts in the past minute about this. And an email. Okay, so okay, I'm gonna change how this works because yeah, I'm gonna put a link in an announcement. And then also I'm gonna do these presentations and all that and then upload them on Mondays. So that people who miss have all of the weekend to catch up. And yeah. That should, I'm gonna give them a second to get it. And then make sure we're all good. That's weird. None of my guys on the other recitation had that. I'm gonna change that. Yeah, because this is confusing for everyone involved. Okay. Back to what I was saying with this. Let's see. Okay, so yeah, all it's talking about is basically where you're adding, like, it's retrosynthesis. So I'm adding this and this to get to here, and it's saying the A like reaction is created from basically this cut. So this product right here is equivalent to this right here. Does that make sense for the first one? And then this right here is equivalent to this right here for the A. Does that make sense? Yeah, I got 1 or 2 minutes. Cool. So yeah, this is something that really, it's just kind of tedious. You've just got to spend some time and look at it. This first one was literally, there's just each substituent with a different number of carbons. So the first one has 3 carbons right here as the Grignard, and then the other one has 2 substituents and 1 substituent. This is like number of carbons, carbonyl. Yeah, carbonyl, sorry, alkane. yeah, I don't know what else to say for this. Do y'all have any questions on this? I felt like this is like the hardest thing to talk about because it's just a matter of practice. Spend some time breaking these down and looking at them. It's a lot of just bookkeeping and counting carbons and getting comfortable with basically just the mechanisms of Grignards. And yeah.
Could you, sorry, could you do one like from scratch? Because if I'm being honest, I'm just completely lost and have no idea what's going on.
Yeah, for sure. So let's take, for example, how much time do we have? I don't want to run out of time here. I'll take like a couple minutes to do this. Okay, so here's one. So let's say we want to make one from right here, this break. To make that break, we've got a counter carbon. So 1, 2, 3, 4. So we need 1, 2, 3, 1, 2, 3, 4. And then our carbonyl is on the third carbon because this alcohol has to turn into a carbonyl. And then this break right here is going to be where we're making our Grignard. So the Grignard is going to be MgBr and then 3 carbons. 1 carbon, 2 carbon, 3 carbons. And that's all that is. So then the Grignard is going to act as the nucleophile and hit the electrophilic part of the carbonyl group right there, which will send these electrons here. And when that happens, that leaves this for the acid workup. So the acid workup just basically allows this bad boy right here to come around and have an acid to attack, to turn it into the final product, which is an alcohol. Like that. Does that make sense? Yeah, cool. So it's basically doing that in every single different way you can do that. When I did this, now I'm going to I'll erase everything real quick. And I think the tricky part here is, now I'm doing this because this is the majority of the challenge problem. So I want to make sure you guys get this. Let's say this is the thing where I'm cutting. 1, 2, 3, 4, 5, 6. 6, is that right? 1, 2, 3, 4, 5, 6. Yeah, that's right. And then the third carbon is the one with the alkane or the carbonyl group. And then right here is where we get the MgBr. So we only have 1 carbon, and that's this carbon. And so once again, whoop, does that make sense? All right, cool. Moving on. Actually, I won't even bother with that. That's all of these. Hopefully that explains this concept. Oh, wait, no, I can see the chat. I can pull it up. Yes. Yeah, and if you're in Dr. Valu's, I've posted supplemental content like videos with or like documents with videos. So this first one is just a Grignard. This is really important. So this is basically all of these reactions are all you'll need for the challenge problem. Well, and your synthesis toolkit that you'll create. So here we've got just regular Grignard reaction where we've got this guy acting as the nucleophile, and that will create this. And so that's the first part. Hopefully you see that 1 carbon, 2 carbon, 3 carbon, 1 carbon, 2 carbon, 3 carbon. Yeah, that's all you need for that one. Then right here, this is one of the many ways we can do elimination is heat and sulfuric acid. And so we get this. And from here, we're going to do all kinds of fun stuff. So in one way, we're going to do basically like a lower pressure and lower concentration of ozonolysis so that we won't break up the benzene ring. And so you're going to actually create 2 products per C. So one product is going to be cut from right here. Can you guys see that right here? And then the other one is just going to be this huge benzene section. And so, yeah, that's all that you need for C. And then from C, we're going to do one of the easier organometallic reactions. So we're using lithium and carbon, a methyl group. And so that can go ahead and basically break in each of these electrophilic sites from the carbonyl groups. And so when you do that, you create this guy right here, and then I'm also creating this guy right here. And in the process of doing that, there's also the acid workup, which is where I add another hydrogen. Oh wait, no, I'm not adding another hydrogen. Yeah, I'm adding the hydrogen here. This is what I was talking about. There we go. And that's that. So that's F. So does anybody have any questions about that section? No? Cool. Okay. Moving on to from D to, or B to D. So from here, we can also do peroxides and what is it? An halogenation. Well, no, that's not even that. Anyway, using peroxides and bromic acid. And so that's just going to add anti-Markovnikov. Hopefully you guys see that. And then this guy right here is going to basically do the same thing. It's just anti-Markovnikov oxymercuration, or not oxymercuration. Sorry, I'm mixing up my terms today. And that's that. So D will be here, and then E will be here from the different reactions. That was talking about this one and this one. Hopefully you guys see that. And then very first Orgo Orgo 2 reaction that we did was just the this one that is going to do like an SN2 switch from like an alcohol group to a BR. And so H is just the same thing as D. It's just that this right here that's written in red. And so from here, we're actually going to do a Grignard for, so D and H are the same thing. Okay, we've established that. From D to G, we're doing a Grignard. And so to do that, you can just add it and draw it in. And then basically this bond right here is going to attack, and you're going to extend it out, the carbon group. And so that's what's going to create the alcohol, or where the alcohol is going to be created is on that Grignard. Because it was the one that had that thing, the carbonyl group. Does that make sense, guys? Yeah, cool. All right, awesome.
Could I see F real fast and I, just so I can take a picture of it real fast?
Which one?
F and I.
S? F. You said
Yeah.
F.
Yeah. Okay, I got it. Thank you.
Yeah. Yeah, and hopefully you guys saw PCC. Yeah, I don't know if I talked about that. PCC on these alcohols, if it's a tertiary alcohol, PCC is not going to be able to oxidize it. So if you created another bond here, that would be 5 bonds on this carbon right here, and that just can't happen. Think of it, that's one way to think about it. And then over here, when you're oxidizing it, you're moving that, and yeah, that can happen. That's how you get from F to I. So these are the challenge problems. Same deal as last week in terms of group assignments. You guys did really, really good with your, what's it called? Okay, so I'm going to ignore all the leaving masses. This is technically office hours now, and so basically I'm going to go over all this part 1, and then I'm going to go into part 2. So part 1, basically we're just using a Grignard and adding it to these aldehydes and a ketone. So when you add a Grignard to an aldehyde, which is like a terminal ketone, you create something that's got a secondary alcohol. Well, it's a secondary alcohol. Then when you use a Grignard with a with a ketone, you create a tertiary alcohol. And so that's that for A and B. C and D are something that we've kind of incorporated, and I didn't do as much with epoxides, but now they like want you guys to know epoxides a lot because it is covered on the ACS. Like every year, there's been one problem that's used epoxides with Grignards, and it's been really confusing. So they're covering it, and so anyway, basically you've got breaks here, and then on both times because you've got it labeled actually where it's going to be in the final structure. So basically the same thing in terms of that component of the molecule on both of these D and E, or sorry, C and D. Only difference is this D one has this methyl here, and that methyl is going to be right there on that one. And that would be how you make like a secondary alcohol from this same epoxide method. And so on that note of making alcohols, all we've got to do is match these up, and we've got our finished products. So for one Grignard reagent, you can count your carbons and do 1, 2, 1, 2, and then we need to add 2 carbons there. So we're adding 2 for our Grignards, and I mean I've got it highlighted already to kind of make sure you guys know. For part E, you can use dichromate or chromic acid or PCC for this one. So when you've got a secondary alcohol can only go to a ketone. It can only go up 1. And so you could even use chromic acid, even though chromic acid is the heavy duty bad boy. Dichromate is the same thing as PCC. They'll work in the same way, or functionally for the synthesis as far as we're concerned. Dichromate would have, chromic acid would have taken this all the way to a carboxylic acid. So it would have looked like that instead of an aldehyde. So that's just something to know. Now we're going to go on to the challenge problems. So these are best worked. Really, you use some retrosynthesis, or you can go, like I was saying earlier, you want to be burning the candle at both ends when you're working these synthesis. Look at where your ending product is and where your final product is, and just try and get closer and closer to connecting them. For this one, if you remember that you can use epoxides, like this is a really easy problem for the first one, because all you've got to do is add your magnesium and ether solvent, and voila, you've got a Grignard. And then you can just react that with an epoxide. And when it does that, you've got 1, 2, 3 carbons here, 1, 2, 3 carbons here. And then this is the new carbon bond that's formed from the epoxide. And so this is what's getting broken here. And so you're going to get carbon here, correlates to these 2 carbons. And then this these electrons are falling back into this carbon. And so when you do the acid workup, that makes it into an alcohol. Does that make sense? Yeah, cool. And from there, you can use PCC because we're making an aldehyde and not a carboxylic acid. Oh crap, wrong button. Sorry, iPad is no on charge. There we go. And then the other way you could have done that was using Grignard reagent and then just reacting it with a 2-carbon thing, 2-carbon aldehyde. And so when you do that, let's see, did I actually do that? Yeah, I did, because it's going to be, it's going to be internal, but you don't want it internal. So you're going to, if you were to do that, that would mean that you have to have a lot of extra steps. You'd have to use heat to eliminate to get a double bond. And then once you've done that double bond, you would have to add an anti-Markovnikov fashion and then do PCC. And that is not efficient. And so you might get dinged some, but that's just, it would work. It would not work well. So, so this is the second one. And so the second one looks busy because there's 2 different ways you could solve it. And some classes taught one way, some classes taught the other. I just figured I'd throw them both in there. So you can use Mg, you can just drop magnesium with it and ether right off the bat. And so, well, actually, I'm going to take a step back. So, our starting product has 3 carbons, and we know our final product has 4 carbons. So we're going to have to do something where we react it with either Grignard or like a formaldehyde. So that's what this is, formaldehyde, where we've got just a carbonyl carbon, and that's all we've got with 2 hydrogens. And so there are multiple ways you can make that right, make that work. The first one would be that I thought of would be just to immediately drop Mg on there and make this into a Grignard reagent. And from that, all you have to do is react it with a carbonyl group, the formaldehyde. And from that, you'll create this here terminal alcohol, so a primary alcohol. And you can eliminate that to make this double bond thing here. And then you can just do acid and water, or you could do oxymercuration. It's just going to add it in a concerted fashion, same deal. And then once you've done that and you've created this right here, you can use PCC and turn it into a ketone. So that's one way.
Could you draw real fast the arrows for the first reaction, the MgBr to the carbonyl?
This one, or this section, or wait, I'll use my highlighter. This one or this one?
No. The second one. The one with 2 steps in it.
This one.
Yeah. Could you draw the arrows for that one?
For sure. So what we've got here is we've got bonds right here coming out and punching this guy right there, which causes these guys to come up here. And so when we redraw that, we've got 1, 2, 3, 4. And then this is the 4th carbon here. It's attached to this guy like that, which looks exactly like this. So this is the product of step 1. The product of step 2 is just that.
That makes sense. When I was looking at it, I just for some reason in my head the carbon count wasn't matching, so I was just confused.
Yeah, I do that a lot, and I have to second guess myself, and sometimes don't ever ignore that feeling because it's worth a shot.
I definitely did that today. I made that way more complicated than I needed to after looking at this.
It's okay. I mean, what you guys did was how you did it last semester.
Exactly, like with the H2SO4 and all that.
Yeah, and I mean, it worked out. It's just not really what we're doing on this test. So
yeah, this was way easier.
Yeah. The other way you could have done it is just using your normal SN2 mechanism. So you've got a terminal halogen, and so you can just substitute that for an alcohol, and then make that into an aldehyde by using PCC. And then you've got just your normal Grignard reagent, which will attack right there, and you do the acid workup, and it comes out like this, which is easily turned into the final product of a ketone by using PCC. Does that make sense? Cool. All right. So that's a really good problem because you got options. There's a lot of ways you could do that one. And then this is the very last one. So this last one starts off with a double bond on the external part of the alkane, or I guess it's and you're just going to use a little bit of BR. I think this was supposed to be like a THF. Yeah. I think that's right. I don't remember. Is it? Yeah, it is. Okay. Yeah, that's all the components I need. Anti-Markovnikov hydroxyl on the end there. Then you're going to use PCC. When you do that, you make an aldehyde. So that's what you need there. And then the last part is just using the Grignard to go directly into the last bit. And yeah, that's all. So hopefully you attack this right here. This guy comes back and makes another carbon in your final product. Yeah, that's all. I guess this one you could also do it with, instead of this, you could go, oops. And this is just like another little bonus. Yeah, that would be BR there. Just kidding. Don't do that. You would want to use, what was it? Isn't it peroxides? And
Yeah, like HBr peroxides.
yeah, exactly. That's what I was thinking of. There we go. And then we can turn that into MGBR and react that, I think. And from there, we go on to make my drawings pretty. The formaldehyde. And so, but no, actually don't do that. Just kidding. Because the thing is, here at this point, the product of that is going to be, you got your fifth guy here, but this is going to be here. And that means you have to eliminate it and then go back with acid and water. Does that make sense? So like, that's just incredibly inefficient. Don't do that. Anyway, all right. Well, that's not really very good. Do you guys see what I was talking about or thinking about? It doesn't matter if you don't, because it was wrong. All right. Good job. Cool.
Can I ask you a quick question?
Yeah, what's up?
How did you organize like your reactions? Because I made flashcards and I'm still doing that, but I don't know if it's better to like also have it written down like as a notebook format.
Yeah. If you're doing flashcards and you're writing a lot of here, wait, actually I'll stop the recording real quick.